So we've got Steve from Save9. He's going to introduce himself. He's brought water and a bag. Very good. Over to you, Steve. Introduce yourself. You've got a clicker.
Clicker, please. Yeah.
There you go. Over to you.
Good afternoon, everyone. My name's Steve Bromham. I'm from Save9. I've got a couple of colleagues with me here today as well. One person in particular is Rebecca Nettleship. She's a theoretical physicist and is working with us on a program to help us look at the different types of sensor technologies at a more technical level. Presentation today really is about our journey. Save9 is a 2002 established business that provides IT and network solutions. And we got to a position where we were asked about broadband facilities where we are based, the locale, which is on the east coast of Yorkshire. We're based in Scarborough, and there's a rural landscape out there with terrible broadband connectivity. So we started basically getting into the networking business initially by working with a rural broadband initiative program through a company called Ninet. Now, Ninet is wholly owned by North Yorkshire County Council, and they came to us and said, right guys, you know quite a bit about network connectivity and managing data. Can you help us out? We want to report to multiple public sector locations the quality of the network connectivity that we're putting in for them. Now, Ninet, it was EU funded, big project all over North Yorkshire, from the east coast, from Scarborough up to Whitby, across towards Harrogate, Ripon, back down again, York, across to Malton, back again, a big ring, a big fibre network. And we basically set up an open source solution in MySQL, which is a database package now owned by, the license is owned by Oracle. But at the time it wasn't. And when we set it up, we managed to track live packets of data from Cisco routers at 563 locations. And that generated about 19 million records of data. So we had some experience in data right at an early stage in actually analyzing it and presenting it in a nice GUI for a network manager or an IT manager at, say, a hospital or perhaps based at a council office. So that's what we started off doing. We moved office and we got to this beautiful Georgian villa called Woodend. This is where we used to be based, our office. And the reason why we moved there is we needed more connectivity, and they had a Ninet link in there, funnily enough, and it was a government-funded project, so we had lots and lots of bandwidth we could play with. Someone found out about the fact we had lots of bandwidth. In fact, it was a hotel, again, on the coast, and I'd mentioned already, internet's pretty awful in rural locations generally. It's getting better, of course, thanks to Ninet and super fast initiatives, but this hotel really needed better broadband for its guests, because people were actually checking online and the hotel booking websites to the speed of the internet connectivity, and they were losing money. They were losing bookings. So we said, well, yeah, we've got a link we could potentially do. We've not done it before. We've done a bit of Wi-Fi for companies and for public sector organizations, and they asked us to do a feed for them, because the cost, I think it was going to cost 20K just to put a leased line in, just the capital costs, civil engineering costs, to put it into that hotel. So we did it for a lot less than that. And we did a link, wireless point-to-point link, and we managed to give them about 450 meg throughput. They didn't use all of that, but we had the capacity. And it was quite a good experience, because from the back of that, the council found out that we were doing it, and they said, oh, we're not far from there. We've got this big visitor centre called the Spa Complex. Our internet's pretty terrible too. So we said, oh, right, okay, so we bounced a link off the hotel. Can you all see it at the top? That's the hotel I showed you earlier. And we bounced the link down to there. So before we knew it, we'd actually built this wireless network. Then the open air theatre, they had terrible internet too. So someone said to us, look, you guys do internet to the hotel, and you do internet to this the Spa Complex. We need it too. Before we knew it, we were building this wireless network, point-to-point links, across the town of Scarborough. So we thought, just a minute, there could be some money in this. So we decided to go and buy some land. And on that land was an old Yorkshire water reservoir, which had been imploded and closed down. So we bought a mast and some land. And here's one of my guys on our mast. Somebody mentioned Arkiva. It was Barter, wasn't it? You probably recognize that. That's a red zone mast as well. You're not supposed to go near it, and if you go up it, you have to go up with 2 people at a time. It's that bad. The intensity of the RF waves up there is pretty awful. So we can't spend too much time on our masts, by the way, when we're near the Arqiva mast. Someone had the idea as well recently to put one of those, like a London Eye up there, similar sort of concept, one of those roving wheels, and they had no idea what they were going to cause in terms of medical problems for their customers, but we won't go into that. Microwave their customers. So this is the south view. We can see for miles. I think you can probably get the gist of this. So we've suddenly opened up our entire network as a fixed wireless internet provider. So that's to the south of our first tower. That's to the north of our tower. And now we're rolling out other towers, and I'm putting in license agreements, not heavy-duty legal contracts like leases, with farmers, landowners, and we're building up a network of towers across the East Coast. We're extending into caravan parks, building base stations, and I'm going to get to the point soon, ladies and gentlemen, but what I'm trying to show you all here is we have an infrastructure, and off the back of that infrastructure, we can now offer, and we want to work, because at the beginning of this journey, we're right at the beginning of the IoT journey, this is what we hope to do. We hope to deliver on our two primary masts, which are about 20 meters tall, a LP1 connections to sensors. And the sensors that we are thinking of delivering, we're using the same business model that we used with the tourism industry. It was our locale, it was the open-air theatre, it was the hotel, it's the B&Bs that we serve, it's the farmers who are in the agricultural settings around us that we're serving, we're providing high-speed internet to. We see a lot of flooding problems. You've probably seen stuff York or Malton, a couple of places in North Yorkshire that frequently, every couple of years, suffer terrible floods. So we reckon we're in a prime position because of our location to help out. Because of our rural positions of our base stations and our towers, we believe that we can start looking at the tributaries to these rivers to say, look, here are pieces of data, patterns of behavior in perhaps the flow of water and the height of liquids that give an indicator perhaps to authorities or interested parties or even businesses who just want to know if their premises are at risk or their warehouse is going to flood. Giving them ideas that working with partners who have got the technologies and experience in delivering this to actually provide real value. So that's where we are at the beginning of our journey. We have so many inquiries now. We get quite a lot of landowners and farmers saying, look, I need internet. And these lease agreements that we have with them help us on our journey. And I've just gone and bought 3 ex-military masts. Now, it's quite high-end kit. If you imagine the back of a lorry, they use ISO containers. And ISO containers have got a set size because they're designed to be delivered from a lorry to a ship, from the ship to a docking port, from the port back onto another lorry, anywhere in the world. Now, these containers were deliberately designed by Clark Masts as a container base using an ISO base. So we can use a lorry to ship them anywhere very quickly to set up temporary masts. So if you're interested in working with us on a pilot project on IoT, please give me a shout. We've got masts we can have up in a field within a few hours, if you think about it, provided we can get that lorry to pick it up, a low loader, and then we can get these masts erected within minutes. They're based upon basically an air regulator, pressure the mast, air pressure pushes it up to the top, lock it down, you have a ready-made mast with a very stable base. So you can evaluate, do IoT pilot projects that might last months or even years, or even turn it into a fixed mast implementation with some concrete blocks. And the idea is you weigh it down with either sand or cement blocks to keep it stable so we don't want it falling over. I wanted to just use this image to give you an indication of the kind of impact that water levels can have on business and tourism, and having advance notice of it can really save a lot of a cost to companies, such as a pub, for example. Now, a lot of these guys in York, this is a picture of York on the River Ouse, and can you just pay particular attention, please, just to the height of the fence and the bollards and all the people where they all currently are. And this pub here, which you may have frequented in York, just look at the level of the pavement in relation to the windows. And this is what happens when the river floods. Now, a lot of these businesses are all geared up for this. They don't keep anything in stock below the waterline, basically. the water levels go higher than this. They actually do go up to about here. We've seen it before when I've been in York at that level. Now we just feel that if we can give advance notice well in advance, not hours, but perhaps a week in advance, because of the changes and circumstances in water levels, we reckon we can add some real value. But not in the city. We're not a smart city specialist. We're in the rural areas, remember. That's where our infrastructure is. But we do have a belief that there's a feeder to these rivers that stem from high ground, and that's where we think we can help. Now, we do see a lot of flooding as well, particularly in Yorkshire, a leakage. It was mentioned already by a few of you. And having sensors distributed is quite a handy way of actually detecting water leaks much earlier. And it was Barta had mentioned, actually, it was a great point. Some of the technologies like 3G, 4G, they're just terrible for sensors in the ground. You only have to put it a few centimeters above the ground and you're suddenly destroying the propagation quality of that signal. But the thing about the LoRaWAN or other LPWAN technologies is you can actually start putting them under grates. And there's some technologies out there which we're looking at already, we've actually purchased. And it's amazing how many people don't realize what the actual kit looks like, so I've brought some with me. And this is what a gateway looks like, which is essentially the equipment that all of the hundreds or even thousands of sensors communicate with. That's it. Now on that is a network server as well. So you don't really need to have, if you don't want to, an actual cloud service provider. You can capture all of the data on this device and then forward it to a system that you have in your office if you needed to. It just so happens it does have a packet forwarding option where you can send the data onto a cloud provider. And we kicked off this equipment using the Things Network, which is an open source network which you can try out sensors to test your prototyping. Before we knew it, we had to actually advance that and move on to a more private environment, which I'll explain in a minute. But again, that's one of our guys on our tower, and you can deploy sensors in the field quite easily, and the batteries last for years, but it all depends upon how often you're sending data from the device. The higher the frequency of the data packets that you're sending, the lower the battery life. So this is a kit you've just seen. But if we need to mount these out in the rural landscapes high up on towers, we need to make sure that they're IP rated, so that the water, the dust, the high temperatures, the low temperatures don't damage this important kit. So there's some equipment that we're evaluating now before we actually launch our first 3 base stations. As I mentioned, we're very, very early on, but we've got all the theory sorted out. We've got the network testing, the data capture, the analyzing of the data as well. And so we're ready to roll with some partners who want to work with us. This is quite a useful diagram because it explains the simplicity of sensor deployments. You can buy a base unit, this tiny little unit in the middle of the screen, which is where you put your sensor connector to. So you might have an ultrasonic sensor like the one in this photograph in the middle. We attach it via just 3 cables. You seal up the unit by putting the screws on the unit and you deploy it. You might want a water level sensor, you might want a pressure sensor, a temperature, thermometer. All the different types of sensors out there, some cheap and nasty ones. Someone's mentioned that had experiences of that, bad experiences. Beware, you get what you pay for. We happen to use really good LoRaWAN transmission devices from a company called Elsys in Sweden. Fantastic, pretty good on price, but very, very useful because you can connect to digital or analog inputs on the different sensors that you buy. So the idea is to minimize our costs as we deploy. We buy a single type of unit. You can get higher antenna units as well. I've got one with me if you want to see an actual live one, because you'd be amazed. People think they're the size of shoe boxes, but they're not. So this is an ultrasonic one, ultrasonic sensor. And the idea is you can mount it under a bridge or perhaps an overhang, and it points down on the water. And the accuracy of this is it can measure water levels in whatever time interval you want, but roughly 1 millimeter accuracy per meter. So you could do a 10 meter, really quite high up on a fixed point, and just constantly tracking and monitoring the height of the liquid below it. So that's the kind of size. And again, that'll last years on a lithium battery. Okay. There are some other devices which you can use, for example, subterranean. So this is a particularly useful one. Very clever. This is detected if a manhole cover has been moved, either because displacement by water or because of somebody actually breaking in and trying to see what's in the drain. So that's quite good for security. This particular product is fascinating because they've used the switch. All it is a switch, that lever. They've used that as the actual antenna as well. So it's a great idea. Some innovation out there on the sensors you need to look out for. Here's one we developed, a very cheap and cheerful water flow detector. We've got some ideas around that. We've been experimenting with that by connecting it up to one of our LSYS transmitters. We think it'll be quite useful in sports fields where they do a lot of use of water. For example, cricket, we're in a cricket club. We lease a floor where our office space is. So we've got monitoring of water of the use of water at the cricket field. Where there isn't Wi-Fi, they don't want to put a 3G or 4G connection in because it's in a bad signal area perhaps. And this kind of thing allows you to sense there's a bit of a focus here on water monitoring and management. But these guys are really on the ball. They've actually got a satellite imaging system whereby, I mean, it's not their own software, they've brought it in, but they have a technology where the satellites are actually taking photographs, a high resolution, extreme high resolution, of the landscape. Again, typically rural landscapes at the moment. And they're then superimposing interval photographs. So if you can imagine staged photographs at a set interval from the satellite. And then they use some artificial intelligence to look at the differences between the photographs, and they're actually detecting leaks using satellite imagery. It's very, very fascinating. And they have this software suite, which is the Aqua Advanced. I've been invited down to Bristol to look at their operation. I'm looking forward to that. And that particular software package does a lot of what the other packages out there do. But one of the things we became acutely aware of discussing with businesses who are interested in monitoring assets and people and is that they don't want to have a different app for every type of sensor deployment they've got. And that is going to be the biggest challenge. With already thousands of options out there, people do not want to go to a different portal every hour. They want to have one pane of glass to look at. And so these guys have cottoned onto it. So the chaps at Suez have come up with a system that allows you to integrate really sophisticated radio telemetry systems into a less sophisticated, rapid deployment IoT solutions based on LP-WANs. And these are a couple of screenshots. So they're very clever in terms of how they're approaching their business model and selling their software solutions to the water industries. And there are some particularly impressive providers out there which have got very highly calibrated measuring instruments, sensors, which are LoRaWAN compatible. And again, LoRaWAN tends to be a stack that we're particularly comfortable with. And these are the sorts of readings that you can take from water. So, for example, you can look at the acidity levels. You can look at the ions at very granular level, at the chemistry of the water that you're monitoring remotely. But what's critical about this is there's no point being able to do that unless the accuracy of those sensors is very high, scientifically calibrated almost. You can get a lot of cheap and cheerful sensors out there that just won't cut the mustard. And this is where we think we're going to find our opportunities. I deliberately put these map point pins on because I wanted to give you a sense where we think it's going to go. With our masts being high up on strategic locations so that we can deliver fixed wireless internet and IoT, we are going to be putting high-resolution 4K cameras on these masts. They aren't, we hope they're not going to be too intrusive because of their position high up, so there's no privacy issues there, we believe. But the idea is that if we use augmented systems where the sensor data is represented by icons on a landscape and a user can click on that particular icon and get information, the visual side of things isn't just bells and whistles and making the GUI look lovely, it's about people being able to see the environment. So if they are looking at a floodplain, they've got a visual impression of what's going on, and then they can click on a sensor to see a level of a reservoir. So that's our concept. We think that's where it's going to head. And then the concept of hyperlinking, we're all used to it in web pages, but we think that's where it's heading to, where you'll be able to look at a sensor, click on the sensor, and it hyperlinks to it, so it takes you to perhaps a visual. And I have to state that LoRaWAN is not good for sending images. It's terrible. But the idea is that you might use other types of image capture devices in the vicinity. Again, going back to the original start of this presentation, our business was set up around the local economy, the rural economy, the tourism industry. And just to finish off, I think that we'll be able to help people who are thinking of, for example, going to tourist resorts, who look at the smartphone and they say, oh, tomorrow or this afternoon it says it's going to be downpour, it's going to be grey skies. I mean, how many people here have looked at an app, please put your hands up, and they've told you the weather's terrible where you are, but in reality it's beautiful sunshine? Lots of you. And so what we feel is that sometimes these IoT solutions will allow you to look at the temperature, look at the sunshine levels, get a visual, and you want to look what it's like down on the beach, click on the link, click on the hyperlink to the base station looking over the beach. Tap on it, there you are, you've got a visual. That's it, thank you very much.
Okay, thanks very much. That's a fascinating talk, and I think it's a little bit about what's happening now and the future. That's great. I grew up in Scarborough, so I'm really, yeah, that's good. We also need to put you in touch with ICAST, the people who were here yesterday. So there's ICAST, which is about a whole Yorkshire-wide monitoring of water catchments. So we need to put you in touch with them. Any questions? Right, we've got one there. We've got one there from Steve. Anyone else? Well, we're talking, if you've spotted our IoT Things Network gateway on the window, but if you press the button when you're getting a cup of coffee or tea, that goes on our website and tells you how many we've had in here. But we did that to see if we could link it all together. But yes, if you can make sure you press the button in the same way that Steve's doing with his experiments. So, Steve, question?
Hi there, Steve James from Bradford Council. The first is a point rather than a question. Our next use case, we're looking at putting gateways on street posts, street lamp columns. So we've got 60,000 of them. So yeah. You don't need to necessarily install, so have a word with local authorities if you get to that situation. The other one is on dashboards and the likes. It's considering where the sensors are, the types of sensor, but also operationally the people who are likely to need access to that data. They also will be using non-sensor stuff, so they'll be getting cases in from their CRM systems here, there and everywhere, so there needs to be a consideration about not necessarily one dashboard for all their sensors, but how that can link in with the other activities that they need to do that's non-sensor based.
Thank you. And there was a question over here. Any other questions? Great, next one. And then
hi Steve, thanks for the presentation. I'm Jujar Panisar from CentDS. So a few of the things that you're measuring is actually quite sensitive. Stuff like turbidity, iron content, pH, stuff like that. And like you rightly mentioned, a lot of the stuff you buy off the shelf, they're rubbish. You buy 5 identical sensors, the spread on them will be plus or minus 100%. Right. So, and quite often what we find is it's because they're not being well calibrated. Now, if you've got 100 of these sensors scattered all over the place, what are you doing to actually say, all right, you know what, the reading that sensor is giving you is correct? What are you doing for your sanity check? How are you zeroing in and eliminating your errors?
It's a very good point, which you picked up on. Here's an example of a water level sensor. This is a thermostatic one. The accuracy on it could be a couple of centimetres out quite easily. So what you have to do, I think, if you're deploying them, is you have to be the responsible party. And I think you need to calibrate them before, and actually on-site deployment too. So it's quite easy to calibrate one of these. You can stick it in a bucket of water and then look at the reading, the sensor value, and if it doesn't match what it says on there, you can either change it, but then that's accurate at that point in time. But if you fill that bucket of water even further, it could be even more inaccurate. So you have to make sure you're buying decent kit that you've tried and tested, not just one, which might be your lucky one, but you've got to be a responsible party, I think. Pre-calibration and then calibration in the field. That's what I would suggest.
Just to add to your point, what we found is that when we look at these sensors, you can do a lot of calibration, but generally speaking, this is going to touch on what Andrea mentioned in his presentation a few presentations ago. That if you do couple it with stuff like simulations or whatever, then you definitely do get that sanity check. So I was just wondering if you did do any of that, but it's nice to hear that you're also having the same problems we were having. Misery loves company.
In reality, we're too early stage to have done that level of sort of calibration and field, but I would imagine it's like most metering systems that do need to be calibrated at intervals, depending upon the reliability or mean time before failure. So if you see MTBF, that's a specification you need to look out for, because that's when it's going to start deteriorating and might start giving inaccurate results towards the expected failure of that sensor.
Alex.
Do you want to go?
Here you go.
Yeah. Totally agree with your point. Cheap sensors, get what you pay for. Steve, I totally get what you're doing. We've got a flooding thing at the moment. We're not, technology is great, but the practicality is where the rubber hits the road. That's different. People stealing stuff like that. But what the point I want to make is, in the world of IoT, and specifically the subset LP1, we're really thinking about lots and lots of data points. We're effectively crowdsourcing our data. It's just that we create the crowd. Now, if you want a really good sensor, costs money, maybe that's not so much an IoT thing, maybe that's more of an M2M type application. But IoT does have there's a mantra about it. It's very, very low cost, crowdsource things. So without hijacking your bit, Steve, we're doing pothole detection, and we're crowdsourcing our own data by putting super cheap sensors in loads of council vehicles. And they're going around, and we know that the data's a bit wonky in places. But when you've got lots and lots of data, then we put regression models and training data around what we're collecting. And all the rubbish soon sort of like fades away, and as we're crowdsourcing data, I think this is probably into your world of machine learning. We can make best use of the data that way. So cheap data in, contemporary machine learning techniques, super low cost, crappy sensors, it's the way forward.
Thank you.
Yeah, I think
Just one more point, and then we'll...
Mark's all right. I think every IoT thing I go to, sensors are mentioned every time. The lack of affordable indicator sensors, as opposed to high value calibrated airports. I've done now, so it's just
Just for the live stream.
Oh,
Just for the
sorry,
live stream.
okay.
Yeah.
Yeah. So basically, I mean, if you deploy 1,000 air temperatures, give you an indicator around a city, as opposed to one that gives you an accurate, calibrated result, which would you prefer, indicators or actual results? So one of the things we've come across a lot of time is things about road temperature. A council or a customer would want to see 30 streets measured as an indicator rather than actual true figure. So going back to your point, is LP1 is more indication rather than accurate data you want every hour, 0.01%. You prefer to pay £30,000 for that sensor, you're going to put a SIM card in, are you, rather than LP1. So my feeling is LP1 is what you say, is indicators rather than true data. So.
Thank you. So we're running miles behind. So we've got 2 more talks just to go through. But thanks very much.
Thanks.